Hi everyone, my name is Naomi Barrios, and I'm going to do a presentation based on the lab we just performed, which was based on the extraction and purification of eugenol. To begin with, what was the purpose of this experiment? So the purpose of this experiment was to isolate eugenol from clothes using distillation. It is important to keep in mind that we used a specific type of distillation, also known as steam distillation. Now, there's a principle behind the steam distillation process, which is that when the heating of a mixture of two or more immiscible liquids takes place, the vapor pressure exerted by the system increases. This is because it now becomes the sum of the vapor pressure of all the components of the mixture combined. On this slide, I composed a table of chemicals that were used for this experiment, their structure, molar mass, and physical properties, as well as safety to keep in mind when dealing with these chemicals. The two main chemicals we will be looking at, or three actually, will be methylene chloride, eugenol, and sodium sulfate. So to begin with, eugenol, we see that has two oxygens and it has an ether and a hydroxyl group. It has a molar mass of 164.2 grams per mole, melting point of negative 7.5 degrees Celsius, boiling point of 254 degrees Celsius, and sodium sulfate has a sodium yellow atom represented right here with a 142.04 grams per mole, a melting point of 884, and a boiling point of 1,429 degrees Celsius. So it is important to keep in mind the boiling point of eugenol, especially because by performing steam distillation, we're able to lower the temperature where eugenol starts to boil. But how do we obtain eugenol? So eugenol is an aromatic oil extracted from cloves. It is also used widely as a flavoring for foods and teas. As you see here, these are the types of cloves we use for this lab. This is the brand Badia ground cloves, and they look like some granularly sand-like type of substance. So what is steam distillation? Just like you, I'm pretty confused, but I will try my best to explain what it is and hope to create a better understanding of why it is useful and why we used it. So by book definition, steam distillation is distillation of a liquid in a current of steam used especially to purify liquids that are not very volatile and are immiscible with water. So volatility is just saying whether it evaporates quick or not, and that's based on boiling point. We know that eugenol, based on the chemical table shown before, boils at 254 degrees Celsius. Immiscible is in regards to whether or not it's soluble with water. Eugenol does not mix with water, and we will see that later on in the presentation. So this is our apparatus setup. This was the fractional distillation setup for this experiment. Unfortunately, this experiment did not work for me personally, as for my first day, I collected no distillate and was surprised to see why. But when looking at our apparatus, we see we have a thermoprobe, a Claisen adapter, a distillation head, a condenser, 100 milliliter boiling flask, and a heating mantle. There's also a marking on the glass to indicate if we need more water. But what is a Claisen adapter? A Claisen adapter acts as a buffer so that uncontrolled activity in the distilling flask does not immediately carry over to the receiving flask. This is what we were hoping to see, but unfortunately for me, my solution was going higher and higher, so I had to change to the simple distillation setup. The simple distillation setup worked best for me, and I collected more distillate at a faster rate. When analyzing this, I realized that maybe perhaps it was the decrease in volume that allowed for my distillate to increase rapidly. So what I mean by that is for fractional distillation, we had a tube right here, but now we don't. This allows for the vapor to just decrease in volume and spread faster. In continuation, extraction. For the extraction portion, On the left-hand side, the image represents the 20 ml I collected of the distillate. And on the right-hand side is the separatory funnel that I used to separate the eugenol from the water or from the organic layer. In order to separate the eugenol, I used dichloromethane. This was my product of extraction after the extraction, we have a solution composed of eugenol and dichloromethane. But I wanted to go into a little bit about the chemistry that happens in the separatory funnel. So we have to note that eugenol gravitates more towards the nonpolar area, and that in this experiment, extraction is done twice. We know that eugenol is a nonpolar compound, and we also know that polar compounds are soluble in polar solvents, and nonpolar compounds are soluble in nonpolar solvents. The net dipole moment of nonpolar compounds is 0. Dichloromethane is nonpolar solvent, and water is a polar solvent. As eugenol is nonpolar, it is soluble in dichloromethane and insoluble in water. For this case, I had some of the molecules still present in the polar layer just to demonstrate that the extraction had to be done more than once because we would still have some of the eugenol and dichloromethane molecules present in the polar layer. Which explains why this extraction had to be done more than once. In order to obtain as much eugenol and dichloromethane as we can, we had to add dichloromethane more to be able to have the eugenol be attracted to the dichloromethane layer, which is a nonpolar layer, and we'd have more of the eugenol received. Now it's for drying time. So the organic extracts were dried by adding sodium sulfate. Down here in the Erlenmeyer flask, the 25 Erlenmeyer flask, we can see there's like this big white mass substance. That's the sodium sulfate acting as our drying agent. The purpose of the sodium sulfate is to be able to absorb any water that might be present in our solution still. Then I used a pipette plug. The pipette plug just consists of 2 pipettes, one acting as the pipette plug with a piece of cotton inside. And the importance of the cotton is to be able to separate any solids that might be trying to get into our liquid solution. As mentioned previously, we were trying to get rid of the sodium sulfate. So now it is time to boil and get rid of the unwanted. In this case, the unwanted would be any of the dichloromethane that has interacted with the eugenol. So why must we boil? In the flask is a mixture of dichloromethane and eugenol. We have to keep in mind boiling points of both compounds. We know dichloromethane boils at 39.6 degrees Celsius and eugenol boils at 254 degrees Celsius. We used a simple water bath, a heating mantle, and our mixture in the flask to be able to evaporate the dichloromethane and just obtain our pure eugenol. Our final product. So this image is just what we would have seen. Unfortunately, I was not able to capture a picture, but I did obtain a smaller amount, which is essentially what it looks like in the diagram. Now to our IR spectrum. We have an OH straight around the 3521.31 ppm. And then we have our alkenes and an aromatic region in our CO. From here, we can try to identify what the structure of our compound would be. First, we need to predict our NMR. So we realize that we have 9 unique hydrogens, meaning that not the hydrogens present in our molecule are all different. Fortunately, we know what the molecule looks like, which is the diagram up above here, and we can determine how many unique hydrogens and carbons we have. So this is what I have listed the table, and it's just demonstrating my prediction of the NMR based on what I collected. Again, this is what our structure would look like. We would have an aromatic ring, a C single bonded to an O, and an OH group. Now the data I collected is shown in the table down below. I collected 6 grams of cloves. My flask, in order to be able to calculate my mass of eugenol, I had to weigh my flask after the scale was tiered in order to be able to determine the difference of liquid that was present in my flask. So simply I did the mass of tiered flask and eugenol minus the mass of tiered flask which gave me the mass of eugenol to be 0.0987 grams. To calculate my percent recovery, I used my mass of eugenol divided by my mass of cloves multiplied by 100, giving me a 1.63% recovery. That is all for my presentation. Thank you so much for watching.